everyone. Today in this class we are going to discuss about inventory management. What is inventory management? Inventory is nothing but the stock of items we keep in our hand to meet the future demand. The stock of items kept to meet the future demand is called the inventory. What is the purpose of inventory management? The purpose of inventory management is how much we need to order when we are putting the order for the materials and when we need to order. What is the time between the orders and how much, what is the quantity we need to order when we place each order. That is called inventory management. Because when we order in a large amount, then the transportation cost may be less. But what happens? We have to keep it in the stock. When we are keeping it in the stock, the maintenance, the carrying the materials, management of the materials will also we need to spend money on that. So this is called inventory cost. When we are having a large amount of inventory, we have to also invest money in terms of the inventory cost. So that is also not suitable for the companies or the industries. So what we need to do? We need to actually optimize the total process. Means how much we need to order and how much we need to keep in the store so that we'll able to meet the demand. Also, what will happen? That we will also try to manage the cost. Next, what are the different types of component of inventory? The components of inventory may be raw material inventory, in-process inventory or work in process inventory, items being transported and tools and equipments. So, these are called the components of the inventory. Then we'll discuss about inventory control. Inventory control is a planned approach of determining what to order, when to order, how much to order and how much to stock. So, these things are very important in case of inventory control. What to order? Means we need to know that what we need to order. When to order, what is the time in between or what is the period we need to know in between we put our order. How much to order? What is the quantity we need to order? How much to keep it in the store so that the whole process we can manage it properly. The cost associated with buying and storing are optimal without interrupting production and sales. The cost associated with buying and storing are optimal without interrupting the production and the sales. So, we need to optimize the cost of buying and the cost of storing the product or the materials. Inventory control basically deals with two problems. When should an order be placed? Okay, when should an order be placed and how much should be the order? What is the quantity we need to order and what is the time period we need to put the order? This ABC analysis, these things we'll discuss in later. First, we'll complete the, yes, this is called inventory management. This is the general model or basic model of inventory management we can say. So, if we see here, this is the maximum amount or the maximum inventory we keep it in the store. This is the maximum amount of inventory we keep it in the store. What will happen? Every day we are consuming at a same rate. The demand rate is constant. Every day we are consuming the demand at a constant rate. Okay. And for a particular time period, unit time period, we are keeping it in the inventory. Maximum level of inventory is Q. Suppose we are keeping it for a unit time period, then the demand rate is constant. What will happen here? If you see, the maximum quantity is Q. So when we go on consuming the materials, one day it will come to zero. So what we have to do? We have to replenish the stock. We have to replenish the stock. Again the cycle will continue. So this is a basic model of inventory management. So what happens here? If you are keeping the quantity Q, suppose take the quantity as 300 units. If the quantity is 300 units, then suppose the consumption or the demand rate is constant every day, because this is a basic model. Here we have to assume that the demand rate is constant. Suppose the demand per day is 10 units. We are having 300 units. Every day we are consuming 10 units. Then in 30 days, 1 month, you can say unit time period, that is 1 month, we are able to consume the total inventory. Suppose take it 300 biscuits we have in our stock. Every day the demand of the biscuits is 10. In 30 days we are going to complete the stock of 300 biscuits. So what will happen? Again we have to replenish the stock to 300. Again the demand we will consume like that. The rate of demand is 10. So in this way what will happen? We will complete this model will complete the cycle. So what will happen here? The maximum inventory is Q and here it is 0. Again we are replenishing the stock. Again the demand rate is we are consuming at a constant rate. So what will happen? See, this is the lead time. Lead time is the time that we have to place the order and we have to receive the order. Why? Because if we are waiting till the end of the month, suppose this is our 30th day, we are completing the inventory is 0 here. But if we wait, again it will take some days to replenish the stock. So what we need to do? We need to order before the time period, before the completion of the inventory, so that when we are going to finish it, again we will replenish the stock. Suppose on 30th day, we are going to finish the total inventory will be finished. On the same day, we are able to replenish the stock. Here actually the replenishment time, the stock complete and the replenishment time is there is no gap between the replenishment and the stock completion time. So on 30th day only we are going to again put it. Again from the first day only consumption will start. So this is the model, basic model. What will happen here? Suppose this is the 300 units we are having. Suppose we know on 30th day it is going to be 0. What will happen? So when it is going to be 0, so suppose we to put the order and to receive the order, it takes 5 days. So what will happen? So we on the 25th day, we can found that 250 units is completed. So we can on 25th day only we can put the order so that we can get the order on the 30th day. Suppose 5 days we are taking. So on the 30th day what will happen? On the 30th day we are going the total inventory, what will happen? It will be vanished. Again we are going to replenish the stock. So this is the case. Suppose 5 days it is taking to put the order and receiving the order. So on 25th day we can put our order and we can receive on the 30th day. So we can be after completion of the this stock, we are going to replenish it again. So this is called the basic model of the inventory management. So reorder point, we know that reorder means suppose 250 stock is still here. Another 50 units were happening. So this is called the reorder point. And the lead time is between placing an order and receiving an order. So this is called the basic model of the inventory. What will happen here? If you see the inventory, this is look like a right angle triangle. So what is the average inventory cost here? If you see the average inventory, what is the average inventory? Because we are always not having Q level of inventory. Means the maximum level of inventory we never have. The first day only we have the maximum amount of inventory and we go on consuming. So always we try to see the inventory is in average, that is Q by 2. We always take the inventory as average inventory, that is Q by 2. Why? Because the maximum inventory is Q and the minimum is 0. If you go on adding Q plus 0 equal to Q divided by 2. That is called the Q by 2 is the average inventory. And if you see, this is a right angle triangle. Right angle triangle means the inventory is nothing but the area covered here. The area of the right angle triangle. What is the area of the right angle triangle? The area is half base into height. If you see half base, base is unit time, that is 1 month we are carrying. What is height? Height is Q. So half into Q into 1, that is Q by 2. So in overall, if you see, the inventory is always the average inventory, that is Q by 2. So inventory cost is also calculated with respect to the area of this right angle triangle, that is Q by 2. Average inventory Q by 2. Because we never have the maximum inventory and you never have always zero, means zero inventory. So always we are go on consuming, that's why we taking the average inventory, that is Q by 2. We always have the inventory as Q by 2. So we have to also calculate the cost accordingly. So if we see here, what is the economic order quantity, EOQ? Means what is the optimized quantity that we need to keep in the store and also we need to put our order. So that is called economic order quantity. If you see here, EOQ, this is the graph. If you see this figure, the x-axis is the quantity and the y-axis is the cost, total cost. When this is the ordering cost curve. This is the ordering cost, CO. When we go on purchasing or putting our order, then when the amount is maximum, amount is a large amount, suppose in a large amount we are ordering, then the ordering cost is minimum. See this graph, this line, this curve is when the quantity is less, the cost is high. When the quantity is go on increasing, the cost is less. Because when we always order in a mass scale or amount, always the transportation cost, ordering cost means placing the order, all the documentation part, all the processing part, whatever we do, the cost is less. So that's why if the quantity is large, cost is less. If the quantity is less, cost is high. This is the ordering cost curve. If you see this curve, this is a straight line passing through the origin. This is called the holding cost or carrying cost line. If you see this one, if we are holding zero amount, then the cost is zero. If you go on increasing the quantity of inventory or stock, then the cost is also increasing. If you are keeping 0 units in the stock, then the cost is 0. If you are go on increasing the inventory level or the stock level, then the cost is also increasing. So this is called the holding cost. When we add these two costs, holding cost and ordering cost, we get the total cost curve. So when we go on adding the ordering cost and the carrying cost or holding cost, then we get the total cost curve. So the total cost curve, what is our main aim of this? We need to minimize or optimize the total cost. See the point where the minimum point in the total cost curve. So this is the minimum point of the total cost curve. So when we draw a straight line from here, it will meet on x-axis at this point. And this point is nothing but the Q star or economic order quantity we say. This is called economic order quantity or Q star. So EOQ is the amount that we need to order so that our cost will be optimized. So here ordering cost which are associated with the purchase or ordering of materials. These costs include cost of staff posted for ordering or goods, expenses incurred on transportation of goods purchased, inspection of incoming materials, cost of stationery, typing, postage, telephone charge, etc. So, lot of cost actually associated with the ordering or buying of the material. That cost is called ordering cost. Carrying cost like the cost of capital invested in inventories, cost of storage, the loss of material due to deterioration or obsolescence, then insurance cost of spoilage or handling of the material. So these are called the carrying cost or holding cost. What are the assumptions we need to take in EOQ model? The ordering cost is constant, the rate of demand is known and the spread evenly throughout the year. I already discussed that the rate of demand is constant. In a constant rate, we do the consumption. The lead time is fixed. Lead time means putting the order and receiving the order. The purchase price of items is constant. No discount is available here. Discount is not available. The replenishment is made instantaneously. As we have discussed in the previous slide, that on the 30th day, suppose we are going to end the inventory. So, on the instantaneously, we are replenishing the stock. Means instantly अगर 30 days में बुक एंड हो रहा है, इन्वेंट्री खत्म हो रहा है, and on the same day only we are going to receive the or fulfill will fulfill the stock. Stock fulfill हो जाएगा. So what is the economic order quantity formula? So to do that, we have to see the things. This is this model we have already discussed. So first we need to see what is the average inventory. Average inventory means Q by 2. So what is the ordering cost? Ordering cost is the number of orders into the cost, means एक साल के अंदर हम लोग कितना order place कर रहे हैं, and what is the cost of one order. When we are ordering once, what is the cost associated with it and the number of orders. When we multiply the number of orders with the cost of a single order, then we are going to get the total ordering cost or annual ordering cost. So first see, suppose the annual demand is D. Suppose the annual demand is D. So what will be the number of orders? The number of orders will be N by, the number of orders will be D by Q, because in a single order we are ordering Q quantity or amount of the product or materials. Then what is our total demand? Total demand is D. So what is the number of orders? Number of orders equal to total demand divided by Q. एक बार में हम लोग Q amount order दे रहे हैं and the annual demand is D. So what is the number of orders? Number of orders equal to D by Q. So what is our ordering cost? D by Q into C0. Suppose एक साल में हम लोग if we are placing, suppose एक साल में 12,000 हम लोग ऑर्डर दे रहे हैं. If you are ordering, our demand is suppose the annual demand D equal to 12,000 units, and each time we are placing an order of suppose 1,000. annual demand है 12,000 units and एक बार हम लोग ऑर्डर प्लेस कर रहे हैं तो 1,000 units प्लेस कर रहे हैं. So what is the number of orders? Number of orders equal to 12,000 divided by 1,000. 12,000 divided by 1,000 equal to 12. So number of orders equal to N equal to 12. Means एक महीने में हम लोग एक बार ऑर्डर प्लेस कर रहे हैं. Right? Like that, what is the average inventory? Average inventory equal to Q by 2. So what is our inventory cost? If we are keeping one single unit, the inventory cost is CH and the average inventory is Q by 2. So Q by 2 into CH is the inventory cost. So when we go on adding these two costs, we are going to get the total cost. Total cost equal to D by Q into CO plus Q by 2 into CH. So we need to find a minimum point of the total cost. Where we have to to get the minimum point, what we need to do? We need to differentiate this curve or this total cost with respect to D by Q. So on differentiating, because we know when we go for differentiating, we'll get the minimum point. By differentiating, what will we get? We'll get D by dQ of TC equal to D by dQ of this D by dQ of TC equal to D by dQ of this total. So what will happen? So that is equal to minus D by Q square CO plus CH by 2. And we know D by dQ of TC equal to 0 because TC is a nothing but the constant. Total cost is nothing but a constant. So constant differentiation of any constant is 0. So this is 0. What will happen? D by Q square CO equal to CH by 2. So what are we going to get when we go on simplifying this one? We'll get Q square equal to 2dCO divided by CH. What is Q? Q equal to 2dCO by CH to the whole root. So this is the Q minimizes the total inventory cost and hence it is the economic order quantity. Let us denote it by Q star. We always say EOQ equal to Q star, that is 2dCO by CH. You need to remember this formula because a lot of questions we get in different exams related to the economic order quantity. That is called 2 into annual demand into ordering cost divided by carrying cost. उसका total root over. Total root of 2 into annual demand into ordering cost divided by carrying cost. Hence, the optimum number of orders, we know number of orders N star equal to annual demand by Q star. The minimum total yearly inventory cost equal to TC star, that is D by Q star CO plus Q by Q star by 2 into CH. We will get it as root over of 2dCOCH. Let us take this example and we will discuss. An enterprise requires 1000 units per month. The ordering cost is estimated to be 50 per order. In addition to 1, the carrying costs are 5% per unit of average inventory per year. The purchase price is 20 per unit. Find the economic lot size to be ordered and the total minimum cost. Here, another one thing I need to tell that while calculating the total cost, another one cost is also associated with it, that is called the purchase cost, because this is our ordering cost. Whatever the cost associated with our placing the order and managing the order is called ordering cost. But when we are purchasing the material, we have to give some money per unit cost. So we need to have here one cost that is called purchase cost. That is the purchase price of each unit we are paying to the vendors or the suppliers. But why we are not considering here? Because when we are taking the differentiation of this is also a constant. Purchase cost is also a constant. Here the total cost is d by dq, it is 0. This will also 0. So here we are not considering, but in questions we are going to take it. How we are going to discuss, how we are going to solve it, let us see. So this is the question. An enterprise requires 100,000 units per month. The ordering cost is estimated to be 50 per order. In addition to 1, the carrying costs are 5% per unit of average inventory per year. The purchase price is 20 per unit. Find the economic lot size to be ordered and the total minimum cost. Here see how we are going to solve it. What is given in the question? First thing, to solve a question, first you write down what is given in the question. What will happen? In this way, the half of the problem will be solved. If you write what is given in the question, then half of the problem is solved. So, an enterprise requires 1000 units per month. Here, per month demand is given, not the annual demand. Right? So, we need to calculate the annual demand. D equal to 1000 into 12, that is 12,000 units per year. Yes. Then what is next given? Next given 50 per order. We are placing the ordering cost is CO equal to 50. In addition to 1, the carrying cost are 5% per unit of average inventory per year. Because always inventory cost is per unit time, because for a particular time period we keep it in the stock. So the inventory cost is always say the unit of inventory cost is rupees per unit time. So CO equal CH equal to 1 plus 5% of 20. 5% unit of the average inventory per year. The purchase price is 20 per unit. Okay. Purchase price is 20. Carrying cost is always calculated on purchase cost basis, because what we are putting the 5% per unit of average inventory per year. So when we are purchasing a product, we are giving some money. So on the purchase quantity only, we have to calculate the inventory cost. So here, in addition to 1, the carrying cost are 5% unit of average inventory per year. The purchase price is 20 per unit. So see how we are going to calculate here. So 1 plus 5% of 20. C is our purchasing cost, that is 20 per unit. 1 plus 5% of 20 equal to 1 plus 1 equal to 2 per unit of average inventory. Means 2 rupees per unit we need to pay. So, how we are going to calculate the Q star? Q star equal to 2D CO by CH, that is 775 units. So, again question is asked, find the economic lot size to be ordered and the total minimum cost, that is TC we need to calculate. So, TC how you are going to calculate? TC equal to TC, that is TC star plus cost of materials. TC star we have already discussed in our previous slides, that is root of 2DCOCH plus here one cost we need to add, that is the purchase cost. When we are purchasing a single item, the purchase cost is 20. The annual demand is 12,000. So 12,000 into 20, that we need to add. So the total cost is 24 2,41,550, you can say 2,41,550. Let us take another one example and we will discuss. Alpha Industry estimates that it will sell 12,000 units of its product for the forthcoming year. The ordering cost is 100 rupees per order and the carrying cost per unit per year is 20% of the purchase price. Always, actually, in our previous question, it is not in addition to 1. The carrying cost at 5% per unit of average inventory per year. Okay, means in addition to 1, means we need to add 1 here with the carrying cost as we have calculated here. 1 plus 5% of 20, because 20 is our purchasing price of 1 unit. Here it is clearly given that the ordering cost is 100 per order and the carrying cost per unit per year is 20% of the purchase price per unit. What is the purchase price? Purchase price is 50. So find the economic order quantity, number of orders per year, time between successive orders. So when see here how we are going to solve. D, demand is given, ordering cost CO is given, purchase price per unit given, CH we need to calculate, 20% of 50 equal to rupees 10. Then just you need to put all the values and find the answer Q star, that is 489.9, which is approximately 490 units. This is another one example. You are procuring spark plugs for your company from supplier X. You need 18,000 plugs annually. The cost per unit of the plug is 25 and the ordering cost per order is 250 along with the carrying cost of 25% per annum. Yes, find the optimal ordering quantity. The supplier is offering 10% discount on order of 2,500 quantity. Will you accept the offer? Here, a discount price is given on a specified quantity. So, whether we should go for accepting the discount price or we go for our economic order in Q quantity to purchase, that we need to compare in the question. See, CH is always we need to calculate CH is on the percentage of the purchase price of the item. So, the annual carrying cost CH is C into carrying rate, that is 25 into 25%, that is 6.25. So, Q star we can calculate here, that is 1200 units. So, on the base on EOQ, according to EOQ, what do we need to do? we need to calculate the total price. Purchasing cost, total purchasing cost first we will calculate, that is 4 lakh 50,000. Then ordering cost, that is D by Q, that is 3,750. Carrying cost C, Q by 2 into CH, that is 6.25, this is 3,750. So total cost at EOQ on EOQ, the total cost at EOQ. If you are taking the economic order quantity, what will be the total cost? See, I have already discussed that we need to add one purchase cost in total cost. Here we have added the purchase cost, that is the annual demand into cost of one product. Okay, so total cost at EOQ, that is the purchase cost plus ordering cost plus carrying cost, that is 4,57,500. Let us see what is the discounted price. Discounted offer, the discount units is 2,500. The economic quantity is 1,200, that is 1,200, but the discount is given on 2,500. 10% discount, the new cost will be 25 into 10% means in one product we are getting 10% discount. So on with we are paying we are paying 25 rupees. So if you are 10% discount given, then we need to pay 22 rupees 50 paisa. Yes. Then what do you need to do? So new carrying cost we can calculate the CH, because CH is will be calculated on this purchase cost 22.5, that is 5.625. So purchase cost equal to purchase cost 18,000 into, because this is our annual demand, into 22.50, that is 4,05,000. Ordering cost like D by Q into CO, that is 1,800. Carrying cost Q by 2 into 5.625, that is 7,031.25. So total cost with discount we can calculate, that is 4,05,000 plus 1,800 plus 7,031.25. So total will be, this is 4,13,831.25. Okay. So when we go for comparing, EOQ level में मिला था 4,57,500. On discount we are getting 4,13,831.25. So obviously we are getting a discount of 43,668.75 rupees. So we should go for the discount price according to the question, because we are getting a discount here. This is another one question. The same way we need to solve it. Yes. So let us stop the class here. We can, in our next class, we can discuss about the APC analysis and some other topics. Thank you very much.